So let us talk about random access memory, that is RAM. RAM is actually a form of computer data storage, one of the most important part of your computer. And this random access memory, this is a device which allows data items to be accessed. Accessed means read or written in almost the same amount of time. This is very important, same amount of time, irrespective of the physical location of the data inside the memory. So you have a memory, and wherever it is stored, the access time is equal. While in other data storage media such as your hard disk, CD-RW, DVD-RW, or any other old RAM memory, it was not the case. It significantly depends on the physical location, because there are some mechanical limitation such as media rotation speeds and arm movement delays. So this is the difference between RAM and other memory. Now SIM and DIM, this is very important because I'll be using these words quite often in the later slide. This SIM, which is called single inline memory module, this SIM is for single inline memory module, has a single line of connectors. This has a single line of connector, and connectors on each side of the board are the same, and SIMs are now obsolete. This is very important. Now this is obsolete, but we need to talk about this because DIM has come and we need to see the differences also. The DIM actually is a dual inline memory module. This is single inline, this is dual inline memory modules that has two lines of connectors. It has one single line of connector, this has two lines of connectors. So connectors on each side of the board are not connected, and the most popular types of DIM are DDR, DDR2, DDR3, right? And because we are talking about SIM and DIM too often, the differences also, let us see. The SIM pins on either side are connected to each other, while this DIM pins are independent. They are connected, they are independent. And this DIM provides 64-bit channel, which is twice that of 32-bit. So SIM provided 32-bit channel and DIM provided 64-bit channel. And DIMs, this enabled the practice of pairing two SIMs as one because it was required. And DIMs are not backward compatible with SIMs, just like all other memory modules. And the most important is SIMs are obsolete and DIMs are the replacement technology for SIMs. So let us start with the DRAM, that is dynamic random access memory. This is the most popular type of electronic memory. The figure is like this. These are special type of semiconductor that stores ones and zeros using microscopic capacitors and transistors. There are transistors, there are capacitors inside, and this is how the memory is stored in the form of bit, in the form of a number of bits. So single chips can hold millions of this capacitor and transistor combination, and this is how the program execution takes place in your hard drive. How does it take place? This is your hard drive, and this is your random access memory, RAM, and program is only executed when your data is transferred to your random access memory. So CPU only knows about your random access memory. The dynamic RAM organization is like this. DM is considered the standard now, and it has low cost, high speed, and able to store data in a relatively small package. There are many varieties of DRAM, and DRAM stores program and data in the form of bit, in 8-bit, that is 1 byte. So DRAM has 1 byte chunks of memory. So we have referenced this in various forms, this depth and width. So 1 MB into 4, 256K into 1. So there are various ways in which we refer to the depth and width. So depth and width are in the form of this computer terminology or memory terminology. So the depth and width of this DRAM are measured in the form of bits. Remember, these are measured in the form of bits and not easy to determine based on what written on the chips like this, but you do have a configuration where you can find it. And the physical size and the internal organization of the chip are not directly related. We have some memory controller chip, MCC as we call it, and this MCC, this device facilitates the flow of data from RAM here to the CPU. See, it goes to CPU. And data is placed on this external data bus. This is external data bus, and width of the data bus is related to the width of the DRAM. This bus, this is width of DRAM. So let us have a brief bus review. Buses, as we all know, so addresses bus, this addresses the RAM. So the number of line in the address bus, this is if it is the address bus, it determines the maximum RAM. This determines the maximum RAM. So if you have 32 lines, you have 4 GB. You have 36 lines, you have 64 GB. And external data bus also there, we call it EDB, and this is where the data is placed once addressed, as you saw in MCC. And this MCC receives data from this RAM, and these are placed on EDB, and width of the data bus dictates width of the RAM. Then we have FSB. These are front side bus, very important to know. And these are same as external data bus, and we have backside bus. This is used to access the cache. Backside bus used to access the cache. This is how our DRAM sticks look like. This is for, of course, you may find the difference. This is for your computer system. This is for your laptop system. There is one more term which is called banking. You need to know because you are knowing about RAM. So combining the width of DRAM to match the width of the external data bus is called banking. There are width of, the DRAM width and external bus width has to match. So you have to have a banking. This is the banking. And the number of sticks that make up a bank depends on the chipset, which in turn depends on the CPU external data bus size. So external data bus size EDB, then CPU, then your number of sticks. So for example, EDB of 64 bits will have 2 SIMs, 32 bit wide, while EDB of 64 bits, this EDB will have 1 DIMM, 64 bits wide. As you are a consumer, most of you are the consumers, so you consider it like this. If 1 byte is there, you understand it to be 8 bit, and if it word is the RAM has width which are called in word, it will be 16 bit, while in double word it will be 32 bit. However, whenever we speak about 256 MB, 512 MB, 1 GB, 10 GB, 12 GB, all these kinds of terminology are prevalent. Now let us come to SDRAM. This SDRAM is synchronous dynamic RAM. These are tied to the system clocks, that is why they are called system dynamic RAM. They are synchronized with the system clock. SRAM is always a DIMM, but a DIMM isn't always SRAM. This is very important. SDRAM is always a dual inline memory module, and there are wide number of pins. There are small outline DIMM, that is SODIMM. This is used in laptops. These are faster than DRAMs. SDRAMs are faster than DRAMs. Then RDRAM. RDRAM is a RAM bus DRAM. It is a new type of RAM. The speed is up to 800 megahertz. It comes in a sticks called RIMs, not SIM, not DIMM. It comes in RIMs. 184 pins for desktop, and 160 pin for your SORIM, that is for your laptop. So all slot must be populated. Unused slot must have a CRIM. There is another terminology called continuity RIM. So all slots must be populated. There is one more thing which is called latency. Whenever you talk about RAM, so measure of how slow the RAM may be, this is the latency. So if you say a CL2, it refers to low latency, and you say that okay, this is faster, or my RAM is faster. If CL3, it refers to high latency. We say the RAM is slower. So this takes, for example, CL2 takes 2 cycles to get a data, while the CL3 takes 3 cycles to take a data. So this is often referred to as CAS, that is column address string. Then we have parity and ECC, because again RAM, it will have a parity and ECC. Parity was a rudimentary or a trivial method for checking the data to see if error exists. So there is no correction, only detection. While ECC, error correction code, this is a special type of RAM used for a high-end system. Major advances in error checking on DRAM by ECC, and can also correct many errors rather than just detecting. And RAM sticks of any size can be used the ECC RAM, but it is most common as 168 pin DIMMs. So mother must be designed, this motherboard should be designed to use ECC to take advantage of this ACC RAM, this ECC enabled RAM. Again, in RAM we have buffered and registered RAM. So most motherboard they support only 4 sticks of RAM, and most sticks present unique challenges. So till now there are only 4 sticks of RAM which are being supported. So to overcome output problems, sticks add a buffering chip. You have a buffering chip. This acts as an intermediary between your RAM and MCC. This is why we are called this as a buffered or registered DRAM. Then working with RAM, can you find some discrepancy in this picture, or what's wrong with this picture? Yes, this is how you're holding, this is wrong. So avoid ESD damage like this and don't touch pins on connectors directly. Do you need RAM? There will be some or the other thing which you can see in your computer that may force you to think that you need a RAM. So 2 symptoms point to needing a RAM. There are 2 symptoms, maybe general system sluggishness, especially as more programs are opened, and disk thrashing as excessive high driving accessing caused by excessive paging. But no, disk thrashing can also be a cause of disk fragmentation. So there are various things like a doctor judges a patient. You have to judge that whether your system, which is a patient, if you found all these things, need a proper medicine. If you're a Windows user, you can easily find how much RAM your system has. Go to my computer, Windows key, pause, break key, you'll find it here. And if you go to task manager, you just press Ctrl Shift Escape, you'll find it like this. And how to get the right RAM? I have to identify the capacity. What can the motherboard handle? This is very important. The motherboard can handle only specific type of or specific capacity of your RAM, and you have to identify the empty slots. If all the slots are filled, you have to pull out some. Like you can change your 256 by 512 MB. Now CPU Z. This is a great tool to determine what you have. This also shows the latency. How to install the DIMMs? You have to swing these side tabs away from the right and push this DIMM down somewhat hard, and these 2 tabs should move back to the base. They come like this and they go like this. And how to install SOAR DIMMs in laptops? So make sure the system is off, no AC connection, remove all the batteries, remove the panel, or lift the keyboard like this. Okay, now gently slide the pins into the position and then snap the SODIMM down into the retaining clips. These are the retaining clips. Again, troubleshooting RAMs, right, like this. Memory errors can appear. There may be errors that may appear as parity errors, ECC error message, system lookups, page faults, and BSOD. We have real memory errors also, like parity error at this is the consistently the same this address will be, and you have a bad RAM stick. Hopefully you should not get this one anyway, but there are phantom errors also, the random access memory errors, random memory address. This may be due to power issues or dust or heat. This is how you check the RAM. Just halt before the RAM check. This could indicate improperly installed RAM. This is how some error will come. I have faced this. This is what it says, that okay, you have some problem in your RAM. How to test the RAM? Hardware RAM testing devices can be used to troubleshoot error. First of all, hardware RAM testing. And the economical option is to replace the existing stick with new ones. Or you have this MEMTest32. This is a freeware tool, and you can test the RAM using MEMTest32. Now, before I conclude, I just wanted to tell you about the cache, because RAM is very, very close to cache, and they are talked almost equivalently. So, cache memory, this is the fast memory, that serves as a buffer between your processor and memory. So, this is a buffer, which is a cache, and the cache holds data that was recently used by the processor and saves a trip all the way back to the slower memory. So, this acts as a handler in between. It keeps all the secrets, and the types of caches are L1 cache, L2 cache, and L3 cache. This is how the memory hierarchy look like. The memory structure of PC is often thought as just a main memory, like this. This is just a main memory. No, it's really a 5 or 6 level architecture or structure. How? The first two levels are contained in the processor itself, consisting of the processor and small memory like registers, and L1 cache, which is the first level of cache, and this is usually inside your processor only. Okay, then comes the L2, then comes the DRAM, then comes the disk. We have L3 also. So the third level of memory is the L2 cache. This L2 cache is usually contained on the motherboard. This is on the motherboard. Then the fourth level is been referred to as L3 cache. This cache used to be the L2 cache on the motherboard, but now the same processor input L1 and L2 cache on the chip, so it becomes the L3 cache. Usually it runs slower than the processor, but fast enough to be called as cache because it is faster than the main memory. Then the fifth level, as fourth, if you have L3 cache of memory, is the main memory itself. You have main memory itself in the fifth level. And the sixth level is a piece of the hard disk used by the operating system, usually called as the virtual memory. So most operating systems use this when they run out of the memory. So thank you so much. Hope you understood about RAM, and this was very brief idea about RAM. If you are interested, you can go to various links, various videos of mine. Thank you so much. Take care.